Hello, everybody. This is Project Group 3, Assignment 5 recap.
So this week's really been focusing on the build week. So continuing with figuring out the ArduPilot and 3D printing our models and just overall construction of the drone.
Now, the biggest takeaways from the week, like we said, is basically this is our build week. We're trying to get everything put together for the first time and try and get a proof of concept on the ground that we can test. The biggest things that we have on our takeaway here is we have a drone chassis that we need to get assembled, mounting our actual hardware that we've decided on, and then getting the software end of things working for our program. Now, for our software, you may have remembered that we actually ended up deciding to go with the ArduPilot open source software because it basically provides all the basics you're going to need for flying a UAV. It has some automation and it allows remote control, and it is a very good open source software for some of the programming that you need to actually get it to work. And it has tie-ins to Python with its drone, with its kit, which allows us to use a very familiar coding language that's known for its approachability and the libraries within to actually call for other sensors that we're going to be implementing into the drone later on. However, this has come with a number of problems of the fact that the ArduPilot faces a problem that a lot of open source software has, where it is designed primarily for Linux operating systems. Now, it does have tie-ins, so you can work with it when you're using Windows, except for the problem that there's a lot of issues with actually connecting, getting commands to go through, and reliability issues that you need to design certain workarounds in order to get it to work flawlessly. Now, this wouldn't be much of a problem if we had a background with coding. However, we're running into the issue where, as a whole, our group has a good understanding of the basics of coding, so we can build and grow into it. However, a lot of the common problems that somebody that has a more in-depth background would be familiar with is taking much longer for the group to find and diagnose. Like, oh, hey, we're having issues with this communication port, and that is because it is configured wrong in the settings over here. Or, hey, this is just a weird quirk with something that is Python-based, so you actually have to do this. And that's things that you just can't recreate unless you have the experience.
So for our drone assembly, we did end up making a number of changes because of 3D printing limitations and also just because it was the best thing to do. You can see our before and after on the left and right here. The two main changes we did was we beefed up the landing gear. As you can see, we made those bottom pieces a lot thicker. And then these supporting ridges that you can see on top of the arms, we decided to actually put those on the middle piece, and that would help with 3D printing, and also I think it looks a lot cleaner. So next slide, please. For 3D printing, these pieces are actually too big to print all at once. So what we ended up doing was cutting a lot of them into pieces, and then you can see how on the left here, we're just going to print 4 of those pieces and glue them together, which does present a little bit of concern with like stress concentrations and stability, but we think that it'll be okay. And then on the right here, that's the part of the electronics mount with those supporting ridges that I mentioned earlier, and that also had to be cut in half to be able to print. And talking about 3D printing next, I believe, is Morgan.
So in order to 3D print our parts, we actually ended up using the Creality Ender 3, which I have at home. We initially tried to use the 3D printers at the school there. However, we were having some issues with it, so we ended up just using my own resources there. We can see with the picture on the right here is the settings that we put our nozzle temperature at, which is 250 degrees Celsius, and then our bed is at 90 degrees Celsius there. And these are the parts that Travis was talking earlier that we were printing. We did have to do them in sections like Travis was saying, and so on the right picture here, you can see where we super glue them together and how it gives kind of like a top view of it. We are currently still printing one of our other prints at the moment, and so that is why it's not depicted here today, but it will be in the future. Then of course we have our landing gear off to the left here, and then our quadcopter top is off to the right. And the biggest difficulties that we had while printing was the thermocoupler actually cracked due to heat cycling one too many times. And so therefore we weren't able to actually print with that printer because the computer was defaulting to negative 15 degrees Celsius. We weren't actually able to get to that minimum of 170 degrees Celsius that the nozzle needed to read. And another thing that we had an issue was the filament that we have depicted off here to the right. It had too much moisture content in it. And so therefore it wasn't giving us a nice clean print. Although it's not depicted how it was printing, it would actually have air gaps in the print itself. So therefore it was cooling by the time that it would actually hit the print bed. So it just wasn't sticking and wouldn't layer right to begin with. And of course, as stated earlier, with the Ender 3, we actually have a smaller print bed. It's about an 8x8 print bed. And so that's why we had our different components.
So the last few things we have to wrap this project up is to finalize the report. That's going to involve transferring a lot of the written work into LaTeX files, review and revise all that, proofread everything, insert all the proper figures, captions, tables from all these previous assignments and weekly updates, and then develop the actual prototype. So finish the construction. All the printing is going pretty well. So we're just wrapping the final bits up for that. And then the big obstacle, obviously, is getting that flight software working. So after all that, we'll implement the camera and guidance and ultrasonic sensors and hopefully have a working finished prototype. And if there's any questions, feel free to send those to Talon or Morgan or any of the other group members, and we will try our best to answer those for you.